Hello friends, this video on metal and non-metal part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. Once we're done with metals, we know what is physical property of metals, what metals looks like, the chemical property of metals we'll study later. Now let's study what is non-metal. Non-metal is just reverse of metal. So they have tendency to gain electron. So metals has tendency to lose electron and this guy want to gain electron. Correct. So metals want to lose and this guy want to gain electron. So this is my electron and this guy want to gain electron. And please note there are only few non-metals. If you see the periodic table, maybe the next two chapters, most of the elements are metals. There are only few non-metals. I can say that carbon, nitrogen, oxygen, fluorine, and all the noble gases, right? So there are few non-metals as compared to metals. For example, carbon, sulfur, iron, oxygen, hydrogen, etc. But if you see, 50% of the earth is oxygen only. One particular non-metal itself is 50% of the earth. If you see, hydrogen and oxygen are the major constituents of ocean. So non-metals are less in numbers, but they are more in quantity. Most of the things around us is non-metal, right? But the number of non-metals are less. The metals, there are a lot of non-metals. For example, sodium, potassium, calcium, magnesium, iron, copper, zinc. But there are limited number of non-metals. But the quantity is more. 50% of the earth is oxygen. If you see ocean, they are all hydrogen and oxygen because they are all water, right? So, and non-metals are generally solids or gases. If you see hydrogen is gas or solid, for example carbon, except bromine, which is liquid. So non-metals are all solid, liquid, gas, but most of them are solid and gases except bromine, which is a liquid. Again, this is something we should learn, nothing to explain in that. This is all found by observation. Now the next question that comes to our mind is why should we study non-metals, right? So the first thing, if you see the tree takes CO2, carbon dioxide, correct? And then it releases oxygen, correct? Carbon dioxide is essential for survival of tree. Oxygen is survival for our existence, human existence, right? So if you see, it's very critical. It's a very critical thing. If there is no carbon dioxide, no trees. If there is no oxygen, we are not there. So they are very, very critical, right? If you see the oxygen which you get here, we take it. It's very, very critical for our existence. Without non-metals, we will not even exist. The rocket, if you see the rocket which we use for scientific purpose, the combustion happens. It happens because of oxygen. Even if you see any car and all, any car, anything, car or bike or aeroplane, each of these needs oxygen to burn, because if there is no oxygen, it won't burn. If the fuel won't burn, it won't work. So the basic principle behind all these moving things are combustion, right? You take rocket, you take aeroplane, you take bike, you take car. All these work because of oxygen. If there is no oxygen, this won't work. So if you take your car in some planet which doesn't have oxygen, it won't work because the fuel won't burn. If you see the coal has a huge implementation. Coal is a non-metal, right? So for example, in thermal power plant, it is used to generate electricity. Thermal power plant, it is used for cooking in rural areas, right? So coal has a huge implementation. Coal is also used to create cement or something. There, it is used in raw material for a lot of factories. So coal has a huge implementation, and that's a non-metal. So if you see the diamond, the ladies' best trends, they are also non-metals. The carbon, diamond is nothing but carbon. The graphite, which is used for electrode in most of the batteries, if you open any battery, that 1.5 volt battery which you get in the market, it has a graphite, and graphite is nothing but non-metal. The neon lights which you see, neon is non-metal. The helium is used in this air what do you say, air balloon. So this is also non-metal. Sometimes hydrogen is also used, and that's also non-metal. In the swimming pool, they used iodine for disinfection. That is also non-metal. sorry, they use chlorine in this case. Yeah, they use chlorine. They use chlorine for disinfection of the swimming pool, right? So that is also a non-metal. The chips has silicon in that. I won't say silicon is a non-metal, but some people say silicon is a metal. Some people say it's non-metal. Actually, some people say it's the metal ion, where it's neither metal nor a non-metal. So anyway, I just put this. So silicon is used in all the chips, the microprocessors you see. All the chips have silicon because all the transistors are made from silicons. The fertilizers, they use non-metals, ammonia and all. The antiseptics, they use non-metals. Iodine, yeah, iodine is used in antiseptics. So if you see, non-metal has a variety of uses. You take the first thing is our home system, the existence of plants and trees, our existence, and then you use anything, the generator, the car, the bike, where the combustion happens, right? We use petrol to generate power. That is also we use non-metals. The coal for electricity, cooking, diamonds for ornaments, the helium gas, chlorine, iodine, fertilizers. Non-metals has lot of application. Before we go into the physical property of non-metals, let's have a brief history of non-metals. Metals, if you see, were found in 6000 BC. I mean, it was found way early, but non-metals are not like that. So if you see, carbon is the only metal which was found in the prehistoric time, and that too in the form of coal, right? And if you see, after that, it's all 13th century, right? There is no non-metal which was found in BCs. The only one was the carbon, and then phosphorus was found in 1300th century, and that it was used to make explosives. And after that, the next metal that was found or given name was oxygen. And please note, if you see, oxygen name itself was coined in 1774, not very old. Oxygen is 50% of the earth, right? But the name was not given. Why? It is not visible. It is not visible. Nobody knew it exists, right? But if you see, gold, silver, it was all visible, so it existed. People could just pick it up and say, okay, no, it looks like gold, it's orange color, it looks like silver, it's a silver color. But these things, it's invisible, right? Most of them are invisible in the gas form. So it took more time to find these non-metals. If you see, oxygen was found in 1774 itself, and the name was given by Lavoisier. Similarly, nitrogen itself was found the same year by Lavoisier. He did all the experiments and found that nitrogen is a gas, and he gave this name. Chlorine was also found in the same year by Scheele. Sulfur is again another non-metal which is found by Lavoisier in 1777. Hydrogen, if you see, I tell that no, that most of the ocean is hydrogen, but still nobody found it, that there's a gas called hydrogen, because all invisible. In 1783, this guy again, Lavoisier, found this guy, hydrogen. So with this, the point I'm trying to drive is all these metals, non-metals were found very recently, not very old, not even 250 years old. And that's the beauty. This thing existed, but nobody found it, right? So let's start with some physical properties of non-metal. First thing is it doesn't shine. If you take coal, it won't shine, right? There's no shine in that. They are not sonorous. Again, you take the same example, coal. I see coal is the most available non-metal which you can touch, you can feel, right? So if you take coal also, it won't make noise the way a coin makes, right? They're not malleable also. You can't make a coal thin sheet. They're not ductile also. You can't make a wire from the coal, right? They are very poor conductor of heat. You can't connect heat from that. They are very poor conductor of electricity. If you want, you can take the setup. What you can do is you can take this coal like this, right? The battery somewhere here, and then put some bulb, something, right? You add this and you cross a coal from this, and you will find that the bulb won't glow because the coal won't connect electricity. You can do this. And they are generally soft. You see, the coal is not very hard. If you hit with the hammer, it breaks, right? It's not very hard. It's generally soft, right? They have low density. If you see the weight of the coal, if you take, let's suppose, this much big coal, and you weigh this, and if you take this much big iron, you weigh this guy, iron will be much more weak than cold, because density is less. If you see, it's all porous kind of substance, right? Generally, the non-metals, they are very, very low density substance. Although, as I explained, the properties of metals and non-metals, the physical properties, they are exceptions. As I told, because the metals and non-metals name is defined by this property of tendency to lose electron and gain electron, right? And then they found that, okay, they have some physical property, but they have some exceptions also. For example, I told that all the metals are solid, but mercury is the exception. Mercury is liquid. Mercury is a liquid, exception. As I told that metals have high melting point, but gallium and cesium has low melting point. I told that generally iodine, non-metals are non-lustrous, but if you see, iodine is a non-metal, but it has shine. As I told that metal is a non-conductor of electricity, but if you see in non-metal chapter, I told graphite. Graphite is a conductor of electricity. Graphite is a non-metal. So if you see, graphite is nothing but a form of carbon. Graphite is an allotrope of carbon. Diamond is again allotrope of carbon. So there are so many allotropes of carbon. So we're studying a new chapter on carbon actually. In the next chapter will be a different study on carbon also. What are the allotropes? What are the allotropes? Allotropes are nothing but you have elements which have different properties, right? So they are same, they are all carbon, for example, in this case. So if you see, property of some chemical exists in two or more different forms. So they are all carbon. If you see graphite, diamond, coal, right? All are carbon if you see, but all has different properties. This guy shines, this guy is very hard, this guy is good conductor of electricity, this guy is bad conductor of electricity. So all are allotropes of carbon. Allotropes are nothing but different structural modification of elements. So the way the carbon is structured is different. But if you see, all has carbon element. If you go to the atomic level, all these three are combined of carbon. But the way it is structured is different. And that's why it has different chemical properties, right? So the atoms of these elements are bonded in different manners. So we'll learn more about carbon bonding and carbon allotropes in the next chapter. But for now, you just understand that is the exception, that carbon, they are carbon allotropes. In fact, graphite, you can see graphite is a carbon. And also if you see diamond is also carbon, and this is the hardest metal known. I mean hardest substance known, it's not a metal, hardest substance. And we say that metals, non-metals are soft. But if you see, diamond is the hardest substance known and is a non-metal. Also if you see, there's the exception that sodium, potassium and lithium, they are metals, but they are so soft that they can be cut with a knife, and they have low density and they have low melting point. So they don't follow the physical property of. I have used this word metalloid. What is metalloid? It's nothing but elements which are neither metals nor non-metals. So they don't exhibit the property of metals and non-metals. Again, there's still debate going on which all are metalloids, which all are metals. So generally the 6 elements are commonly recognized. I'll say commonly not recognized. There is no concrete recognition on this. Commonly boron, silicon, germany, arsenic, antimony and tellurium are called metalloids. Again, there is still debate on that. So because they are, some people will say silicon is a metal, some will say it's a non-metal. But generally, yeah, the 90% of the people, they are on the agreement that these are metalloids because they have properties which are between metals and non-metals. They have the exact property, mixture of metals and non-metals, and they are difficult to classify actually as metal and non-metal. Now is the question time. Give the example of metal which is liquid at room temperature. This we know is a very simple answer. The answer is mercury. Mercury is liquid at room temperature. Give the example of metal that can be cut easily with knife. We know it's sodium. We can cut with knife. In fact, potassium also we can cut with knife. Which is the best conductor of heat? We have told that silver is the best conductor of heat, and this is a poor conductor of heat. We have told that there is an exception, and that is mercury and lead. They are poor conductor of heat. There is an exception to that. Generally, most of the metals are good conductor of heat, but mercury and lead are exception to that, and they are poor conductor of heat. Thank you. Visit examfear.com to
watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.